Hello friends, this video on hydrocarbons part 24 is brought to you by examfear.com. No more fear from exam. Let's talk about aromatic hydrocarbons, that is arenes. Why they are called arenes? Because they have pleasant smell. They have very good odor. So they are called arenes. Because most of them has pleasant smell. Right? And if you see, most of these has benzene ring, and most of the case you'll see that the reaction happens but the benzene ring is undisturbed. That also proves that benzene is stable, right? And the aromatic compounds with benzene rings are called benzenides because there are plenty of aromatic compounds with benzene. They are called benzenides, and those which don't have benzene rings, they are called non-benzenides. So we see this one. These are all my benzenides. They have all benzene rings. Now we'll talk about the nomenclature and isomerism. So when two hydrogen atoms in the benzene are replaced with two or similar atoms or groups, then three different isomers are possible. So these are my meta, ortho and para. We'll talk about these actually. So if it is at 1, 2 or 1 and 6, for example, this guy 1, 2 or 1 and 6, in fact 1, 2, 3, 4, 5, 6, if you number in this fashion, this becomes 1, 6. If it's 1, 2 or 1 and 6, it is ortho position, this guy. If it is at 1, 3, this is called meta. And if it is at 1, 4, this is called para. So this is my ortho position. This is my meta position, and this is my para position. If you see, in all these cases, I have benzene with two. It's all dimethyl benzene actually, right? But they are all different isomers. One is orthoxylene, metaxylenes, and paraxylene. Right? So when we talk about isomerism in benzene, we generally talk about ortho, para, and meta isomers. Right? So ortho is second position, please remember. Meta is at third position, para is at fourth position. Okay. So let's see the history of benzene. It's pretty interesting actually. In 1825, Michael Faraday first found benzene, and he found the molecular formula of benzene was C6H6. This shows it has high degree of unsaturation. So because it was unsaturated, it was expected to be very, very unstable. But experimentally, when the chemists did the experiment, they found this to be very stable. They were surprised why this is stable, because C6H6 means it has to be unstable, right? Because it has a good amount of unsaturation, and we have discussed till now that the more amount of unsaturation, the more unstable is the compound. So because of this, it took years to assign the structure because nobody was able to give proper structure to benzene. That means you have to give a structure where it has unsaturation plus stability, right? So, and also with experiment was found that it has 3 double bonds. Why? Because it forms triazonide. So that information we had now, that it had 3 double bond, but still nobody was able to give proper structure to benzene. Also with the experiment they found that all the 6 carbon hydrogen bonds which benzene had, they are all similar, right? They are identical. So with this 2 information and a lot of thoughts in mind and some guesswork also, I'll say, this guy August Kekulé in 1865, he proposed the structure of benzene has to be this guy, this structure. He proposed 2 structures of benzene actually, and he told that the structure came in his dreams, that he saw some snakes in this kind of fashion. So these were the 2 structures of benzene which is proposed in 1865, and that's true actually. And then based on the X-ray diffraction data also, it reveals that the benzene is planar molecule, and with that confirms that we have benzene in that shape. We'll not talk much about resonance and stability of benzene because we have already covered that in the previous chapter of organic chemistry. So if you want, you can watch the video on that. So the question is, why benzene has extra stability. So if you see that it has all this electrons clouds here, right? The electrons are delocalized, and we have talked that the more the electrons are delocalized and they are free to roam around, they are more stable. Also, if you see the resonating structure, which we have also discussed in organic chemistry, There's so many resonating structure which is possible for benzene. That also adds to the extra stability for the benzene. Now we'll discuss the condition of aromaticity. The first condition, it has to be planar. If it is not planar, the atoms, the electrons won't be able to move around properly. The second is the complete delocalization of pi electrons in the ring, because that's what makes a compound aromatic. And also it should have 4n plus 2 pi electrons. This is what Huckel has told based on his experiment, that it should have 4n plus 2 pi electrons. For example, if you take the benzene, right, so it has 6 pi electrons, right, 2, 4, 6. So it is 4n plus 2, but n is equal to 1. So you get 6 electrons. So it follows the Huckel's rules. So if you want to find whether a compound is aromatic or not, just apply the Huckel rule, and you have to see other things also, whether it is planar or not, right? But this is a critical thing. For example, if you see benzene, we know benzene is planar and it has 6 pi electrons. So it follows 4n plus 2 by Huckel rule. So it is aromatic. You talk about this guy. It has 2 plus 2, 4 pi electrons. It won't follow Huckel rule, because if you say 4 is equal to 4n plus 2, you get n is equal to 1 by 2. So this is not a aromatic compound. We talk about this. It has 4n plus 2 pi, the 6 electrons, right? So it is aromatic. We talk about these 6, 1, 2, 3, 4, 5, 6, 7, 8 into 16 electrons. So if you put 16 equal to 4n plus 2, you get n as 14. 3, 4, 5, 6, 7, 14 pi electrons. If you put as 4n plus 2, you get n as 3. That means it is aromatic. Similarly, this also, if you see 3 plus 3, 6 plus 7, 7 into 14 pi electrons. So it is also aromatic. It will follow the Huckel rule. This guy will also follow the Huckel rule. So it is also aromatic. It has, you see, 5 into 2, 10 electrons. 10 electrons means n is equal to 2. 4 into 2 plus 2, that is 10. We'll take some examples, explain why this following system is not aromatic. You see this guy. This guy has 4 electrons, right? 4 pi electrons. It will not follow 4n plus 2 pi rule. So it is not aromatic. This guy also has 4 electrons, 4 pi electrons. This also not follow Huckel rule. This guy has 8 pi electrons. So 8 is equal to 4n plus 2. If you do, you get n as 6 by 4. So this is also not following Huckel rule. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.